this stuff. Now I'm gonna assume you all don't know anything. I'll go through every single thing. Now why am I doing this? Because I actually did one time for the primary school kids. I just assume they don't know anything, and then I go through everything from beginning. And then suddenly I realized that there are a lot of things that they really don't know, that people assume that they know. They also assume they know, but actually, when we are going through, right, they don't know. You know what I mean? Like we go through the basic from the beginning, just iron out every single thing. Like for example, okay, just looking at this, do you know what is a where is it? I saw it just now. Okay, these are the things that they need you to know. That means they can test you. Like for example, what's a real number? You know what's a real number? Okay, so you see, we all assume everybody knows. You understand? But actually, we don't know. Like even I myself also don't know. To be honest, just now I was looking at this. What's a real number? I know integers. I know rational number. I don't know exactly what's a real number. Right? So we'll go through all this lah, because all these are important. So as we are going through, if you want, you can copy down. You can take the full sketch, do some copying. If not, you can just I'll just send you the link. You can watch the YouTube video. Okay, I'll do some editing, right? So you can go and watch the thing. So I'm gonna assume you all don't know anything, but I'm gonna ask question and then you all can answer straight away. Right? Nobody will know who you are, unless you want to be here. You can. I got a student who really doesn't mind his face there because it's quite funny. His friends will comment, you know. When we put up the video, it was a YouTube live. Immediately the friend commented, you are here, right? So anyway, without further ado, this is the SEAB syllabus. Syllabus, what does it mean? That means these are the things they can test you. And if they test you, you cannot say, hey, I don't know about this because it's part of your EMAT syllabus, right? Have you all done anything like this before? That means you go through everything that you need to know. Then how do you know what will be tested? Don't know. Just go through papers, right? Just go through the syllabus. Okay, Ken. First one, prime number. What is a prime number? Can you give me example? Prime number. Okay, I'm gonna say your name, Ethan. Right? Nobody knows who you are. Give me an example of prime number. 2. Okay, wait, write down. Okay, very good. 2. What else? 3. Okay. Alamak, what happened? 3. What else? Continue. You can keep talking. 5. 7. 11. Okay, so and dot. So is 1 a prime number? 1? Is 1 a prime number? No, right? Very good. It starts from 2. So what is the definition of a prime number? Yes. What's the definition of prime number? It's a number that, okay, I'm going to help you. This is not a test, okay? We go through together. It's a prime number is a number that can only be divisible by 1 or itself. Okay. What do you mean by divisible by 1 or itself? That means when you take 2, you divide by 2, you get one whole number. Okay, by itself. You take 3, divide by 3, you get 1. You take 3, divide by 1, you get 3. But you cannot take 3 and divide by 4. I mean, technically you can, you get a fraction, right? But we don't want fraction, we want whole number. Okay, so 3, 5, 7, and so on and so forth. Very good. Okay, so that is a prime number. Now, what's prime factorization then? What's prime factorization? The ladder thing. Okay, very good, right? So let me give you an example. How come I cannot? Okay, ladder thing. So let's say we use a simple number 16. Okay, so what's the first thing that we divide by? 2. All right, then this one is 8, right? And then 2, and then 4. Okay, so basically the rest are all 2. 2, 2, and 1. Now, the thing to take note about prime factorization is that you cannot put any other number here. For example, you cannot divide by 4. Why we cannot divide by 4? Because 4 is not a prime number. Now, if it's not a prime number, what do we call it? What's the definition of a non-prime number? Oh, if it's not a prime number, what do you call it? It's called a composite number, right? The opposite of a prime number is a composite number. Composite means you mix different things together, okay? All right, so that is a composite number. So that's the first point. Do you know what's prime number? And do you know what's prime factorization? Simple? All right, next point. How to find HCF, LCM, square, cube, square root, and cube root by prime factorization? So, for example, right, we already did this. So we know that using prime factorization, 16 is equal to 2 to the power of 4. Right? So let's try another number. Let's say I have, let's try 24. Okay, so divide by 2, we get 12. Divide by 2, we get 6. Divide by 2, we get 3. Divide by 3, we get 1. So 24 equals to 2 to the power of 3 times 3. Now, you are supposed to know how to find HCF and LCM. Okay, Ethan, can you tell me how to find HCF? HCF? Yeah, how to find HCF? Yeah, the lowest index, right? So for example, can you tell me what is the answer here? This example? 2 power 3, right? So you have to find what's common between the two, must be common one. So 2 to the power of 3. Okay? Then how about the LCM? Next. Yeah, 2 power 4 times 3. So usually what we do is we say, oh, you got to find, for HCF, you must choose the lowest power. So the lowest power is 2 to the power 3. So it's just 2 to the power 3. Why don't you choose 3, Amelia? Why you never take 3 here? Why didn't we have a 3 over here?
Because 3 is not the lowest.
Why isn't 3 the lowest? I don't see anything here.
Because that one will be times 1.
Ah, very good. It's actually 3 to the power 0. This one is 3 to the power 1. So 3 to the power 0 is lower than 3 to the power 1. You see that? The reason why we don't write here is because 3 to the power 0 is just 1. So we don't write. You understand? We don't write this thing here. But there's actually a 3 to the power 0. Okay? So actually, I mean, if you want to be strict, this is just 3 to the power 0, which is just 1. So we don't write it down there at all. Okay? Done. Okay, so this is LCM. So the next thing is, let's say I want to find the, they say finding the square, the cube, the square roots of all of this, right? So using this, 16. So I know square root 16 equals to 4, right? But how do I know, I mean, in terms of the index, what do I do? What am I supposed to do? Let's say just by looking at this information, what am I supposed to write here? I'm supposed to write 2 square, right? How come 2 square? Because the 4 you can split into 2 groups, 2 square and 2 square. Alright, so therefore square root 16 equals to 2 square. Now how about they give you a question like that, 24 to the power of times k must be a square number. Then what do I need to do? If 24k is a square number, it 24k must be a square number. What is k? 2 times 3, correct? Now, because 24 is 2 cubed times 3. Now, the objective is we want to make sure the power becomes even number, right? So I need to add another 2 and another 3. You understand? I need to add another 2 here. So this becomes 2 to the power of 4. Here, I need to add another 3. So it becomes 3 to the power of 2. And therefore, my square root 24k will become 2 squared times 3. Alright, square root 24k becomes this. But the 24k has to be double. So this will be 4 and then this one is 3 squared. So therefore, my k is equal to 2 times 3, which is equal to 6. Is that right? Next. So this one is fine. Now what about divide? What if they say, okay, I want 24 over k to be a square number? Then what is k? Now it's not times, huh? Now it's divide by k. 24 over k must be a square number. Next. What is k? Yeah? Still? Why? Because you see 24 is 2 cubed times 3, right? I must divide by something, you know, so that the outcome is a square number. That means the power is even. Right? So what do I remove? I remove a 2. I also remove the 3. Do you see that? Remove, take away a 2. So my outcome will be 2 squared. And 2 squared is a square number. Okay, so therefore k is still 2 and 3 in this case. Simple. So the same strategy is used for cube. Cube, for squares, for cubes, for square roots and cube root by prime factorization. For cubes, you need to make power 3, right? I mean the multiples of the power must be multiple of 3. Square root, okay, all this I just went through already. Okay, next. Do you know what are negative numbers? Yes, of course. Who don't know negative number? Do you know what are integers? What's integer? Ethan? What's the definition of integer? Integer. Okay, can, right? So number without fraction. So give me an example of integer. How about -1? Is that integer? Yeah, -1 is an integer, right? Okay, how about rational number? Where's the rational number? Decimal. Again, it's a okay, it's tough. It's not. I mean, we don't see this all the time, right? Okay, that's why I went to find this thing just now. So rational numbers are here, all right? Integers are here, whole numbers are here. So real numbers consist of both rational and irrational. Let's just start with that. Okay, real numbers are both rational and irrational number. Whole numbers 0, 1, 2, 3, 4, 5. They're called whole numbers. You know that. Now integers, -3, -22. Integers consist of both whole numbers and negative numbers. Right? Whole number don't have negative number. Okay. So rational number is a number that is okay. How do we define? We say that it can be expressed as a fraction. If a number can be expressed as a fraction, usually it is a rational number. And then of course the next question, and then what is an irrational number? So these are examples of irrational number. So you mean these numbers cannot be expressed as a fraction? Yes, they cannot be expressed as a fraction. Another way to identify irrational number, right? Irrational number, the decimal, for example, you press in the calculator square root 2, the decimal is non-repeating, doesn't repeat. Okay, the number is random because 2.0.707 non-stop. All right, then how about pi? Isn't pi 22/7? How come pi is irrational? Why? Now pi, the real pi is 3.14 non-stop. Okay, here we're talking about the real pi. 22/7 is the convenient pi. What do you mean by convenient pi? That means in the exam paper they just give you now 22/7. That is the for calculation purpose. Okay, but the real pi is irrational. Real pi is irrational. How about pi over 2? Pi over 2. Is this rational or irrational? I mean, pi over 2. Is it, which category does it fall under? Pi over 2. Rational or irrational? Pi over 2? Okay, this can come out, right? MCQ, right? And then they ask you to circle, 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 right? Pi over 2, is it rational or irrational? Irrational. Okay, let's do a voting. Rational or irrational? Rational. Guess, rational or irrational? Pi over 2. One more time. Rational means number that can be expressed as a fraction. Okay, and if it's repeated, you see with a dot, means it's 6, 6, 6, 6, 6 non-stop. Right? 5, 6 with a line means 5, 6, 5, 6. So there's a pattern, right? Repeatable pattern, right? It's not repeated pattern. Okay, how about pi over 2? Pi is irrational. Why? Because it's 3.14 dot, 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 random number. Then pi over 2, pi, which pi? This pi, this pi divided by 2. Is it rational or irrational? This pi divided by 2. Is it rational or irrational? Don't know. Okay, don't worry. You're not alone. A lot of people also don't know because they don't really go through. Okay, the answer is irrational. Tony. You see? Okay, imagine here is monster. Monster divided by 2 is still a monster. You understand? I chop the monster into half, is still a monster. Okay? That means square root 2 over 2, is it rational or irrational? Square root 2 is irrational, right? So monster divided by 2 is still a monster. You understand? Okay, so it's still irrational. How come this one is irrational? Okay, basically if you square root most numbers except for 9 square numbers where you get one whole number, okay, as long as you square root some, okay, just to test. What is square root 4? Is it rational or irrational? Square root 4. Ethan. Rational because it's 2. 2 is a whole number under this category. Okay. So if it's square root 2, you divide by 2, it is still irrational. So it falls under this category. Okay. This will save you 1 mark. Yes. Right. So if you get 74 upon 100, because you came today, you know irrational is this, you save 1 mark. Okay. Right. So that is the purpose. Right. You go through everything. Okay, real numbers. So what are real numbers? Basically, real numbers are both rational and irrational. Now, you don't see a lot of questions here because they don't really ask you what's real number, correct? They only test rational and irrational for O level. That's the part that's the most confusing. Okay. Okay. For operation means, do you know how to plus, minus, time, and divide? So of course the most confusing one that you're introduced is decimal, sorry, negative number. So for example, we know if we take a -1 times -1, it become a +1, right? And then -1 times +1 equals to -1. 1 times -1 equals to -1. Okay, 1 times 1 equals to 1. Simple, right? So this is the 4 operations. Okay, you need to know the 4 operations of all these things, which I'm not gonna go through, right? Next, calculation is a calculator. Everybody knows how to do that. Representation, ordering of numbers on the number line. I think that's fine. Use of symbol. What does this mean? This one. A minute. Smaller than. This one is larger than. So this means smaller or equal. Smaller or equal because it has got another line at the bottom that looks like the equal sign. This means larger or equal. Next, approximation, estimation, round off numbers to required number of decimals or significant figure. Now, significant figure is the one that is a little bit troublesome. 3.1057. Okay, let's try. Can we round off this to 3 significant figure? 3 SF. What do you get? Usually they'll ask you for 3 SF. Huh? What do you get? 3 SF. This 1. 1. 3.1057. 3 point. Okay, correct. This 3 significant figure. Why? Because this is called the first significant figure. This is called the second significant figure. This is third significant figure. This is called the fourth significant figure. This is called the fifth significant figure. Now there's a rule. The rule is if the 0 is in between two numbers, it is significant. But if the 0 is by itself like that, 0 0.1, 2, 3, 4. Where is the first significant figure? Which one is the first? Is it this one? Do you count this? No. This becomes the first one. First significant figure. If the 0 is 0 0.0123, right? Which one is the first significant figure? Which one is the first significant figure for this? Ethan? 1. It's still this one. Okay? 0.0101. Okay, is this 0 significant? How come it's significant? Because it's in between two numbers, right? So this one is significant, but this one insignificant, this one also insignificant, right? How about 0, 0, 0, 0? Are these significant? No, these are insignificant, right? The 0 has to be enclosed by two numbers, then it's considered significant, okay? That's the rule for this. So these are minor things for here, significant figure. Now, what's next? Okay, use of standard form. A times 10 to the power of n. Now, what do we need to know here? There are two things you need to know here. When you are adding or when you add or subtract, or when you multiply or divide. So for example, if you have 3.0 times 10 to the power of 8 plus 4.0 times 10 to the power of 7. Okay, what's the first thing that we need to do? When we are adding, you need to make the power the same. Make power same. Okay? Versus when you multiply or divide 3.0 times 10 to the power of 8 times 4.0 times 10 to the power of 7. Right, so let's talk about addition. Now, how do we make the power the same in this case? What do you mean by power the same? The power, this is the power, right? The 8 and the 7, I should make the same. Okay, Ethan, how do I make the same in this case? Can you tell me what's the next step? Very good. So 3.0 times 10 times 10 to the power of 7, then plus 4 times 10 to the power of 7. Okay, so then this 10, right, will join with the 3. So it becomes 30 times 10 to the power of 7 plus 4.0 times 10 to the power of 7. Okay, what's the next step? Factorize the 10 to the power of 7. So it becomes 30 plus 4 times 10 to the power of 7, which will become 34 times 10 to the power of 7. Okay? But we know that 34 times 10 to the power of 7 is not standard form. Why is this not standard form? Must have a decimal. So I need 3 0.4. So I take out 10, right? Times 10 times 10 to the power 7, right? So can you see I took out the 10? Therefore, I will end up with 3.4 times 10 to the power 8. Okay, and therefore the final answer is this. So of course, you don't have to do all this working. I'm just doing it to show you what do we mean, right? I'm assuming you all don't know anything. So this is what I mean by you must make the power the same. Okay, we are shifting the 10 here and there, right? So it looks like you just took 3 and then you plus this together, so it becomes 3.4 times 10 to the power 8. So some students confuse. Now in the exam, the fastest way is just to use your calculator, right? But for significant figures, sometimes they ask you to show working, right? So you gotta show working. You gotta show working in this way. Now, how about multiply and divide? If you're multiplying, all you have to do is to take this number times this number, which will give you 12, right? And then this use indices, 8 and 7, so become 10 to the power 15. And of course, this is not standard form. It has to be 1.2 times 10 to the power 16. Okay, right? So when you are multiplying or dividing, just take the number times the number, and then here use indices to add them up, right? So that's the rule. Now with this simple rule, of course, there are many multiple types of questions that they can ask. Yeah, all right. So that is this standard form integer. Next, positive, negative, zero, and fractional indices and laws of indices. This is our favorite, right? Can you tell me what are the 9 rules of indices? Laws of indices. Okay, I'm going to write the question and then you'll tell me, right? So first one, okay, Amelia, what's this?
A n plus n.
Yeah. So of course the next one is divide, n minus n. Okay, the first two is same base, different power. The next two will be different base, same power. Okay, sorry, different base, same power. B power m. Okay, Ethan, what's this? An times bm, what do you get? Sorry, nearly tricked you. N. This n. 8 power n times b power n. Yeah, power n. Okay, then the next one a over b power n. Okay, change it. A 0 equal a negative n equal and a n power m equal a n times and I mean a 1 over n equal n root a m over n equal n root a power m, right? So you need to know this, then we can do the laws of indices, right? Zero fraction. So all this is under numbers and their operation. You need to operate. You're like a surgeon. You're operating numbers. Okay. Oh, okay. Actually, there's another one. It's called the Bodmer's rule. That's not here. Do you remember the Bodmer's rule? Something you learned in primary school. Bodmer's rule. Okay, what's Bodmer's rule? B stands for what? Operate bracket first. Right? Operation. What's operation? It's actually our indices. Okay? Divide, multiply, add, and subtract. So that's the rule. Okay? Later we see. So I know Because you're Sec 4 now, you are actually very good with all this. But I just go through. Okay, next, ratios involving rational numbers. This one I'm going to go through. Write a ratio. Oh my god. Okay, everyone knows this. Map scale. So map scale, they can only test you two things: distance and area. So we know that for map scale, it's always the form 1 is to n. For example, 1 is to 20,000. Now there's an assumption that you have to make. What's the assumption that you have to make? If they give you 1 is to 20,000, what do you need to know? Ethan? Are they in cm or meters? Yes, it's always centimeter. They're not going to write the unit. But if they write in this form, 1 is to 20,000, is confirmed centimeter. Okay, so this is the map, this side is the map, this side is the actual. Now there's another conversion that you must know. The conversion that you need to know is 1 km is how many centimeter? 1 kilometer is how many centimeter? Okay. 100,000, very good. Why do we need to know this? Because once I know 1 km is 100,000 cm, immediately I know this is 0.2 km. Okay, 20,000, 1 is to 20,000. Immediately I know it's 0.2 km because 20,000 divided by 100,000, I get 0.2. Why do I want to do that? Because of the second part, you see, the area scale. So we call this the linear scale. So when the question involves area, Amelia, what do we do? Square it, yeah. So 1 times 1 is 1. Then 0.2 times 0.2. What's 0.2 times 0.2?
0.4.
Oh. What's 0.2 times 0.2? Without calculator. Oh, what's 0.2 times 0.2 without calculator? 0.2 times 0.2. Trivial question. Yes? Don't know. 0.04 km square. Okay? 0.04. Of course, yeah, I mean, during exam, you get calculator. So 0.04 km square. So just remember, you must know how to convert to linear and area scale. Okay, depending on the question. Next, do you know direct and inverse proportion? Now, what's the formula associated with direct proportion? Yeah, y equal to kx. And then the inverse proportion, y equal to k over x, right? So usually this are question you must find k. They will give you y, they give you x, and find k. All right. So I think that's good now. Yes, very good. So this n2, we know n2. This like nursery, nursery 1, nursery 2. Yay! Now we graduate to nursery 3. Okay, percentage is actually easy because you've been doing it since primary school. Express one quantity as another, compare two quantities. This one I'm not going to go through. Okay. Okay, average rate, average speed, no need. But this one difficult. kmh to m per s. For example, 300 kilometer per hour. Okay, how to convert to meter per second? How to convert to meter per second? Now what I do is, now 300 km per hour is the same as 300 km per 1 hour. Right? So 300 km, because I want meter per second, right? My 300 must convert to meter. So 300 km is how many m? What's the conversion? 1 kilometer, how many meter? 1,000 meter, right? So if I need to convert km to m, I need to times what? Look at the number. 1 times 1,000. So 300 must times 1,000. So become 300,000 meter. Okay, now 1 hour is how many seconds? 1 hour has how many seconds? Oh, 1 hour how many minutes? Excuse me, people. One, 1 hour has how many minutes? What? 60. Then 1 minute has how many seconds? So 1 hour has how many seconds? Yeah, 3 seconds. Is it the question I asked too simple? Is it? That's why y'all look at me. Why Mr. Teng asked this simple question? Okay. Later I'll ask more difficult one. Huh? So you use your calculator. Just press your calculator, which I should get one. Wait, yeah. So you want to convert to meter per second? Just do this method, okay? Take 3,000 divided by 36. We will get 83.333 meter per second. Okay, so just do the individual conversion. So what is the method? The method is do individual conversion. I know some schools say, oh, you just go and times by a certain number, times by a certain number. I find it a bit too difficult to remember. I just change the numerator, change the denominator, get the calculator, do the job, okay, to do the conversion. Because it works for everything. For example, how about density? 5 gram per cm cube. I want to convert to kg per meter cube. How? How to convert? 5, okay, make it bigger lah. 500 gram per cm cube. I want to come on, my G, double G, okay, GG. 500 gram per cm cube. How to convert to kg per meter cube? Just take the numerator. 500 gram is 0.5 kg, right? Then 1 cm cube is how many meter cube? Wow, this one is tough. Because 1 meter equals to 100 cm, so 1 meter cube equals to 100,000 cm cube. Okay, 6 zeros. So you want to convert from cm cube to meter cube, you need to divide by 1 million. So this is 1 over 100,000 meter cube. Okay, press everything into the calculator, let the calculator do the job. You'll get the answer. Right? So my algorithm is always the same. So I'm not afraid. You want me to convert whatever thing, it doesn't matter. Yeah, right? I mean, I'm not scared, because I just use the same, convert the numerator, convert the denominator, then just divide. That's it. Okay? Rate and speed. Next. Okay, next, of course, is the most important thing, yeah, which is algebra. So algebra is like 75% of the entire paper. If you don't know algebra, then that's it already, okay? But of course, you know algebra, yeah? So using letters to represent number, interpreting notation, for example, you know A, B is the same as A times B, right? A divided by B is A over B, or it's the same as A times 1 over B. Because you take the A times 1, so it's A over B, same. A squared means A times A. A cube is A times A times A. A squared B is A times A times B. Alright? I think everybody knows this. 3y is the same as y plus y plus y, or 3 times of y, interchangeably. 3y is 3 times of y, or it's the same as y plus y. 3x plus y is the same as 3 times x plus y. Yeah, this is 3 plus y over 5 is 3 plus y divided over 5, or it's the same as 1/5 times 3 plus y. Right, all these are inbuilt into you. Now, next few, they can test you evaluation of algebraic expression and formula, translation, simple, real world situations. They've been doing a lot of questions on that. Pattern question, yeah, pattern and relationship, you've been doing question on that. That's why they give you, because it's inside here. Addition, subtraction of linear expression, simplifying, things like this. So do you know what to do? Yes, you rainbow in, right? Okay, rainbow. So -2 times in. So we get -6x plus 10 plus 4x. And then after that, the x term and the x term evaluate together become minus 2x plus 10. How come the number and the alphabet we don't evaluate together? What's the reason behind this? How come the number and alphabet cannot mix? Because x is unknown. We don't know what's x. X could be 10, 20, 30, 40. We don't know. So we just leave it as a container. Okay? How about here? If it's a fraction, what do we do? Ethan, I want to evaluate this fraction. What's the first thing I need to do? Ah, very good. Okay, which is, what's the common denominator in this case? 6. So here must times 2. Top also times 2. Here times 3. Top also times 3. So when I multiply by 3, do I just times this 3 or do I have to rainbow everything? Which one is it? Do I just times 3 or do I have to take the 3 times 3 and then 3 also must time inside? Yeah, just times 3 because it's just 3 times of this whole thing. Alright, so this one times 2, so it becomes 4. Outcome is just 4x over 6 minus 9x minus 5 over 6. Okay, so once I have the common denominator, I can operate the top. And it becomes 4x minus 9x minus plus 5 divided by 6. Okay, can you tell me why this one is a plus? Okay. Yeah, because the minus sign here actually rainbows in. This negative 9, right? Rainbow inside here. Negative 9 times. Oh, so I got this wrong. Negative 9 times negative 5 become positive 45. Okay? Right? That's why it's a positive sign. Okay? Then after that, 4x minus 9 becomes negative 5x. That's it. All right, use brackets extract common factor. Do you know how to extract common factor? Factorization of linear expression of the form ax plus bx plus kay plus kby. What does this mean? This is actually grouping. So let's just try this. Now, how do you factorize this one? Grouping. Grouping. What do you do?
Get the common multiple.
Yeah, so we group 2 by 2, right? So what's the common between these two? Take out x. So left a plus b. And then the common between these two? Yeah, plus ky. So left a plus b. Alright, next we extract a plus b from the 2. So a plus b x plus ky. Alright, so this is called grouping. And this happens when you see 4 terms. 1 term, 2 term, 3 term, 4 term. When they ask you to factorize 4 terms, the first thing that comes to your mind is grouping, right? So this is what grouping is about. Okay, expansion of product of algebra expression, changing certain formula, right? We are all very familiar with that. Okay, next, yeah, 3 special algebraic formula, right? This is the one that I asked you all to memorize. A plus b squared, a minus b squared, a squared minus b squared. So I think you'll know this very well. Okay, factorization of quadratic expression. How do we factorize? We use the wait, do you all use this one or do you use detector? I don't remember. Mix up already. Which one do you all use? This one. Okay, so the younger generation they all use this, right? So this one don't care. So use the factorization. Let me give you an example. 2x squared plus 3x plus oh sorry. Oops. 2ab. So 4x 8x. No, 16. 8. Okay, so what do we put in front? This is the 2x squared. And then here we put the plus 4. And then here will be the 8x. Okay, so we line this up. Okay, so I'm going to go through. This should be okay, right? So this is factorization. Multiplication and division of simple algebraic fractions such as this. This is multiplication. So when they are multiplying this, do you need to make the denominator the same? Multiply, this multiply. Do you need to make denominator the same? In this case, times. This one times this. No need. Why? Why no need? How come? How come just now this one need? What's the difference? Because there's a minus sign. Now minus sign is like when you have 1/3 minus half versus 1/3 times half. When it's multiply, you just take the numerator times numerator, denominator times denominator, right? Okay, so it's the same as what's over here. So what's over here is you just simply take the numerator times numerator, denominator times denominator. Okay, you don't have to make the same common denominator. So here you just multiply and then you just divide accordingly. Now, if it's division, then what do we do? If there's a divide, we change the divide to what? Yes, to times, right? And then what do we do to this? Flip, right? So they call this the KFC method. You know why it's called KFC? 1/8 squared. Okay, because you keep this, you change this, then you flip this. Change, divide to times, flip 9a squared over 10 become 10 over 9a squared, right? KFC method of division. All right, so yeah, so here's another example. You must know how to do all this. So for example, if we have a fraction like that, what is the common denominator in this case? What's the common denominator? If I need to add these two.
X minus 2, x minus 3.
Yep. So here got the times x minus 3. Here must times x minus 2. Bracket. So it's x minus 2, x minus 3. Okay. How about the one at the bottom? This one is quite clear cut. Okay. Ethan, this one, second one. Very good. How come? How do you know must time x plus 3? So, yeah, which is our rule number 3 of the factorization. Okay. Next one. Okay, this one is easy. So you just need to times another 1 time of x minus 3. Top and bottom, right? So you get this. Next. Okay, coordinate. Cartesian coordinate in 2 dimensions, so it's the x, y. So for example, if I have 3, 4, this is x and this is y, right? Coordinate system. Graph of set of order pair represented. Okay, now my linear function y equal ax plus b. What does a represent in this case? What's a? Yeah, b. What's b? What's b? What's b? Y in the set. How to find a? Rise over run. Another way to find a? Yeah, y1 minus y2 over x2 minus x1 minus x2. Okay, how to find b? Eden? Sub. x equal to 0. Very good. Okay. Next one, quadratic function, right? So this one, graphs of linear. Okay. Okay, how to find gradient, positive, negative gradient. Graphs of quadratic function and the property positive, negative coefficient x squared. Okay, so we went through all this. We used the 3, 6, 9, 12, 2, 3, that 12 graph pattern. Okay, to help us to recognize all this. Maximum minimum point. Okay, so this is the form, complete square form. Now, just by looking at this, right, can you tell me what is the minimum point? First one. First equation. Can you tell me what is the minimum point? Yes. Okay. Sorry? P comma Q is the minimum point. Right? So what is the algorithm? So what's the method? You take this value, if it's minus P, the minimum point is positive. If it's positive P, you will put negative P. So just times a negative 1 to it. Just take this number and just pop it over here. This will be the minimum point. And why is this called minimum point? Because it's a positive x squared curve. Because positive x squared curve is happy curve, U shape. Right? Okay? Right, so many other variations, this one never mind. Okay, graphs of power function of the form, and then graphs of exponential, you see, y equal k a to the power x. And what I'm going to do is I'm just going to draw the 12 graph patterns here, how we remember this, right? So positive, negative, to, oh, not enough space. Okay, so the first iteration is linear. So y equals to mx plus c. If it's positive, it's just upward sloping. If it's negative, it's just downward sloping. Simple. Next, second iteration. Okay, I'm just going to write all the equations first. Next type is y equal to x square, y equal x cube, y equal, okay, y equal x, 1 over x. Y equal 1 over x square, y equal k a to the power x. So for positive x squared is U shape, negative x squared is N shape. X cube positive is S like that, negative is S this way. 1 over x is what we call the DBS bang, positive like that, negative like that. 1 over x squared is the positive volcano, negative volcano. Right, and the last one is the bowl shape. Like that bowl, or like that bowl, upside down bowl. Okay, so these are the 12 graph patterns, right, that you have to memorize. Because they're not going to give it to you, right? So it's actually shown here, see? For all the different powers of n, negative 2, negative 1, 0, 1, 2, 3. You can see 1, 2, 3, 4, 5, 6. 6, yeah? Corresponds to this. 1, 2, 3, 4, 5, 6. And the positive and the negative. So must know, right? Next. Okay, solving linear equation in one variable. Example is y equal, sorry, one variable means x plus 3 equal 0. So what is x equal to?
Negative 3.
Yeah, x equal to negative 3, easy. Okay, solving fractional equation. All right, so every time we see this, yeah, what's the first thing we do? Let's look at the first one. X over 3 plus x over 2 over 4 equal to 3. We always do this first thing. Ethan, what do we do? First equation. Times 3. Here times what? Then this one times 3, right? So basically what you mean is we combine. We want to combine the equation. So we get 4x over 12 plus 3x minus 6 over 12 equals to 3. And then we combine them, so we get 7x minus 6 over 12 equal to 3. Okay, then what do we do after that? Ethan, continue. Times 12. What times 12? The whole thing times 12. Whole thing, okay. So whole thing times 12. So you get 7x minus 6 equal to 36. Okay, so what's the objective? So it doesn't matter how complicated they give you. The objective is always to get a fraction. This is what you call a fraction equal to something, or this can be a fraction as well. The objective is always get a fraction equal to a fraction, because from there you can cross multiply and you can get one line. One line become linear, right? So linear is the easiest form to solve. Right, so same thing here. Now if the x is at the denominator, doesn't matter. Just treat this as a fraction equal to fraction. Do cross multiply. Right, so 3 equals to 6x minus 12. Okay, just cross multiply. Okay. Okay, next, do you know how to solve simultaneous linear equation in two variable? Either using the substitution or the elimination method. Okay. Now, elimination method, substitution method is the same. Basically, you want to make one of them the same. All right, solve quadratic using factorization, which you already know. Use of formula. Okay, what's the formula? X equal to what? Yeah. What's the formula for quadratic equation? Okay. Okay. Plus minus square root b square minus 4ac over 2a. All right. Or complete the square. Okay. Amelia, what do we do? How do we complete the square? Let's say this is the equation. What's the next step? Okay, step 1, always make sure the coefficient is 1, right? The x square coefficient must be 1. If it's not 1, you cannot complete the square, right? Then after that, what do we do? Let's say this is the equation. P, something to do with this. What do we do with this? Then you square it, right? So next step is x squared plus px plus p over 2 bracket square minus p over 2 bracket square, then plus q. Okay, Ethan, what's the next step? Something to do with this tree. What must we do with this tree? Plus p over 2 bracket square. Right? So you got to refer to your three special algebra formula. In fact, it's just the two, right? Combine them. Then this part basically just use a calculator. Use a calculator. Okay, next graphical method. No need to do here. Okay, how to solve fractional equation? Like this. If you have a fractional equation like this, basically this whole thing is also x plus 3 over 1, right? Then you just cross multiply. So 6 equals to x plus 4 times x plus 3. And after that, here you rainbow. You get a quadratic equation. Rearrange everything. Do quadratic factorization. That's it. Okay? But the next one will be slightly more troublesome this time. But just now Ethan already said, combine the fraction. Okay, formula integration, solve linear inequality, one variable. Okay, this one no name. Number line. Okay, so you see, algebra. Wow, we spent about 45 minutes just talking about algebra. All these are algebra stuff, which is the majority of the things that you need to know, right? Okay, all this algebraic stuff. Okay, so the rest are easier already, yeah? So for example, set notation, you just need to know the meaning of all of them. Union, this A union B, this one intersect, and so on and so forth. This is an element, this one means not element. This complement, complement means everything outside of A. This one empty, universal, this proper subset, this not a proper subset. Union, intersection of two set Venn diagram, right? Okay, matrix. So interpreting scalar quantity matrix, how to add and how to multiply two matrices. Okay, what is the rule of thumb for matrix? Row time column. Take row time column for matrix. Okay, last but not least, real world context. Travel plans, transport schedule, sports, game, recipe. All right. Personal household finance, compound interest, taxation, installment, blah, 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 blah. All right, all this stuff. Right, interpreting data. Okay, next is angles. I think you all know this, right? Right, acute, obtuse, reflex. Reflex is the outside. Okay, vertically opposite angles or straight line angles at the point. Two parallel line, transverse, corresponding angle, alternate angle, interior angle. What are all this? So there are a few letters you need to know. We call this the X, and a C, and a F. Okay, so if X, these are called vertically opposite. This is interior. All right. So this is corresponding angle. All these are parallel lines. Parallel lines. Then what else? Okay, polygon. Now what are the two formulas for polygon? Evelyn? Polygon. There are two formulas you know for polygon.
N minus 2 times 180.
Yep, n minus 2 times 180. What does this give us?
Total sum of integral.
Yeah, then the sum of exterior equal to
360.
exterior, this sum 360. Okay, pentagon. Okay, they only have this few, you see? Pentagon, hexagon, octagon, decagon, including symmetry property. Okay, pentagon, how many sides? Peter? Pentagon, how many sides? Hexagon, octagon, decagon. No, one of them is wrong. What's decagon? Then what's decagon? No, okay. 5, 6, 8, 10. Okay. 7 eh? What do you call 7 side? Anyone? Heptagon. Hepta. 9 side eh? What 9? Nonagon. But how come they don't have it here? I don't know. So they specify 5, 6, 8, 9, 8, 10. Decagon is 10. How do you know decagon is 10? DEC. DEC come from the word decimal. What's the meaning of decimal? 1 divided by 10 equal 0.1. So decimal, so it's 10. Okay? It's not December. December is 12. No. Decimal. So it's 10. Alright? Classifying special quadrilateral based on their property. Okay. What do we call this? Parallel. Yeah. What do we call this? Only two sides equal. Okay, all parallel, but two sides equal. Only two sides equal. What do you call that? Then there's another one, all side equal and this one all equal and all parallel. Okay, which one is a rhombus? This one, right? This guy is a rhombus, all side equal. This guy is just called a parallelogram. This is a parallelogram. Okay. Just in case they ask you to draw. Okay, angles on interior exterior, we already know that. Perpendicular bisector, angle bisector. Okay, how do we draw this? Okay, construction, yeah? Construction. So what's an angle bisector? If you have an angle like that, you take your set square, cut here, then from here, draw an arc view, angle bisector. How about perpendicular bisector? They'll give you a line, use your set square, draw an arc here, straight line across 90 degrees, perpendicular bisector. All right? So that's what I need to know. Whoa, next one. Similar and congruent. What's the meaning of similar? One big, one small. All right? How about congruent? Congruent means exactly the same. Now, similar triangles, if one small, one big, only the angles are the same. The lengths are not the same, right? So the lengths will differ by a number. For example, here is 10, here is 5, here is 8, here will be 4. But the angles are all the same, right? Congruent means exactly the same. Exactly the same. And we use 3 lines to show congruence. Right, next. Okay, so properties of similar triangle, polygon, corresponding angle equal, sides are proportional. Enlargement, hey, I don't think y'all do this, right? Do y'all do enlargement plane figure? I never seen an enlargement plane figure question. Scale drawing, okay, determine whether two triangles are congruent or similar. We use the rules, right? What are all the rules? A, S, A. Okay, for congruent, A, S, A, S, R, H, S, 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 S. Okay. Okay, ratio of similar solid. This one I need to go through a quick one. For example, if I have a cup, one big, one small. The radius here is 8 and the radius here is 2. Okay, the volume, okay, so the scale is 8 is to 2 or 4 is to 1. Okay, in terms of the length, huh? Now, if the volume here is 10, can you tell me what is the volume of the small cup? The number very bad. 40. Yeah, this one bad. Also very bad. Too difficult to calculate. Okay, what is the volume? How to find this is a linear scale. So if I want to compare volume, what do I do to the ratio of the radius? I must cube it, right? So the volume, cubic scale, right? 1 is to 4 times 4 times 4 is 64. Yeah. Okay. So you must cube. Then with that you can find the volume. That's what they mean by similar solid. Right? Don't go and find the whole thing. Don't go and find the volume of a cup. Not possible. Okay, symmetry properties of circle. 1, 2, 3, 4. Now, how do we remember that? All these we remember it by using 6 circles. 1, 2, 3, 4, 5, 6. The first two, they are the two angles. One here. Oh, okay. So the one in the middle is twice the one at the side. Here, like that. Okay, these are equal. And then the next two is 90 degrees. This is the diameter, so here is 90 degrees. You must touch this part. Perpendicular here, 90 degrees. Next one is cyclic chord, dot, dot, dot. Okay, here plus here, 180. And the last one is the kite. the kite thing. Like that, like that, like that. Okay, so this one equal to this one. Alternate segment theorem. Okay, so they're all here. 1, 2, 3, 4, 5. This one is the cyclic chord, right? Alternate segment theorem. Angle ascended is twice angle. Okay, these are the reason. So you must write the correct reason. Okay, these are all the reasons for all this stuff. Okay, so must know, must memorize. Pythagoras Theorem. A squared plus B squared equal to C squared. As long as it follows this rule with a 90 degrees triangle, A, B, C. A squared plus B squared equals C squared. It is a right angle triangle. Next one, trigonometric ratio, Toaka. So I think everybody knows that. TOA, CAH, SOH. That reference angle, theta. This part is called the adjacent. This part is called opposite. This part is called hypotenuse. That's it. Next one. Aha. This one is what do you mean by this? Sine and cosine obtuse angle. What's that? What's this obtuse angle thing? Yeah.
More than 90 degrees.
Yeah, but what's the rule? What's the rule?
180 minus 30.
No, but how is it used here? How is it used here? I give you an example, right? Angle A. This one is obtuse, right? Obtuse. So angle, let's call this angle T. Yeah. So how do we use this, Ethan? The obtuse angle rule for sine and cosine. What is the obtuse angle rule for sine and cosine? Do you remember? Something to do with negative something. Do you remember it? Sine A equals sine T. Because for sine rule, if you sine the acute, it's the same as sine obtuse. But for cosine, cosine T or vice versa, cosine A equal to negative cosine T. Okay, so for cosine is negative, but for sine is the same. That means you sine the acute is the same as the sine of the obtuse. But if you cosine the acute, obtuse is the same as cosine the acute. Sorry, negative cosine the acute. Alright, so you must know this rule. Okay, so sine rule, cosine rule. Okay, what is sine rule? What is that? What is sine rule?
Sine A over A equals to sine B.
Okay, sine A over A equals sine B. Sine A over capital A equals sine B over capital B. Alright. What is small letter A? What is capital letter B? What is small letter A and what is capital letter A? What's the difference?
The side.
Yeah, which one is the side?
The opposite the angle.
I mean the capital letter or small letter? Small letter A, is it the angle or the side?
The angle.
Yeah, so small letter A here, the opposite here will be capital A. Alright, small angle B here, opposite will be capital B. Alright, next one. What is the cosine rule? Ethan, what's cosine rule? Using this. What is the cosine rule? Cosine rule they give you actually, yeah? But do you remember? A squared equal to B squared plus minus 2 2BC. It's okay. Cosine what? Capital A. But don't really they give you. But you need to know small letter A, what does it mean? What's capital A? What's small letter A? No. This one is Emilia's one, so cannot use. Right? Different things. Small letter A here refers to the length. Capital A refers to the angle. Right? For this cosine rule. Right? So formula half AB sine C is the area of a triangle. So you know that. Sine rule, cosine rule done. Two dimension. Okay, can. Parallelogram. Okay, how to measure this? Okay, so all this, the good thing about all this one, cube, prism, cylinder, pyramid, cone, is that the formulas are given. That's the best part, yeah? So you don't have to worry too much, right? Okay, next one, arc length, sector area. Okay, what's the formula for arc length? Okay. Given also, but do you remember? Huh? Arc length, arc length equals r theta, the formula. Theta over 360 times. Oh, okay. 180 degree equal how many radian? Pi radian, right? So pi over 2 radian equals to how many degree? 90, yeah. Correct. 2 pi radian, how many degree? Why must look at each other? 360. Okay, good. So this is the conversion, right? You need to know the conversion. This one must memorize. This one is not given. This is not given. Conversion between radian and degree. You must memorize this. 180 degree over pi radian. So arc length r theta. What is the area sector formula? Half r squared theta. Okay, where r is the radius. All right. Oh, coordinate geometry. All right, finally. Finding the gradient of a line. So we already said that. Finding the length. Okay, what is the formula for length? Amelia.
y1 minus y2 square plus x1 minus x2 square. Then the thing must square root.
The whole thing square root. Okay, interpreting finding equation, straight line in the form y equal mx plus c, and geometric equation. So vector this year no need. Okay, all thanks to who? To the lady in Wuhan, right? That ate the bat, right? That caused COVID in the whole world. Now how many million? 6 million, is it? Infected the whole world, 6 million, right? 5 million or 6 million? Was it 2 million? Infected, no, because she eat the bat. 6 million kena the COVID, no. Power. Till now, we haven't identified who's that fella, right? Okay, haven't finished. Data analysis. Table, bar graph, Pythagoras line chart. Okay, all this easy. Don't have to go through. Okay, stem and leaf. Stem and leaf, just to make sure you know what we're talking about. 1, 1, 2, 3, 4, 2, 3, 5, 7, 3, 1, 2, 5. Okay, usually this type of stem and leaf, they will give you the what do you call that? The key. They'll give you the key. So this will mean like 11, 12, 13, 14, right? So the tens, we put it here. So this one will be like 23, 25, 27, 31, 32, 35. Okay? Simple, everyone? Okay, this is not what I want. Okay, box and whiskers. Box and whiskers. Usually there's like a number. How do you draw that? Is it like that? One number. Okay. So the n here, this is the range. Smallest number. Okay, let's say here is 10, and this one is 50. Okay, that will be the range. So the range is from 10 to 50. Smallest number to biggest number, right? Then how about here and here? What can you tell from these two? The two end of the box. What's the two end of the box? Lower quartile and upper quartile, all right? This one is lower quartile, this one upper quartile. So when you take the upper quartile minus the lower quartile, what do you get? The thing starts with the letter I. Yeah, interquartile range. Very good. All right. So we get the interquartile range. Then how about the line in the middle? What's that for? Oh. Oh. What's the line in the middle? Okay, we gotta do a. What starts with P? Sorry, I forgot. Pole. P-O-L-L. Okay, let's do a pole. What does the line in the middle mean?
Median.
Median. What does the line in the middle mean? Median. What's the line in the middle mean? Random. Middle. Middle means medium. Okay, correct. Median, not average. Okay, because there is a difference between the three M. Mean, median, mode. Right? Mean means average. Mode means the most. Right? Median means the middle number. So well, the median is the one that is a bit confusing. So for example, 1, 2, 3, 4, 5. Which one is the median? 1, 2, 3. Which one is median? 3. How do we know 3 is the median? How come 3 is the median? Yeah, because got 2 here and 2 here. Can you see that? It's balanced in the middle. You get it? So let's say I have 2, 3, 4, 5, 7, 2,000. 1, 2, 3, 4, 5, 6. Okay, which one is the median? Where's the median? 4. Why? Because you must split into half, This one half. This one also half. The median is in the middle. So you gotta take 4 plus 5 divided by 2. So it's 4.5. Okay, I'll give you another tricky one. Tricky one. Very tricky one. Okay, smaller number. No, we all want to fall asleep. Right? 1, 2, 3, 4, 5, 6. Okay, which one is the median? Tricky. Which one is the median? Come. Median. 3 plus 5 over 2. Okay, how about you? Which one is the median? 4. 3 plus 5. So it's 4. Same as her. Okay. Why? Why you all say 4? Why you all never choose middle here? Why you all so clever? Why you never choose middle? Isn't it 3 plus 7 divided by 2? Huh? No, why? What's the problem? Because you must rearrange, okay? The sequence 2, 2, 3, 5, 7, 10. Must rearrange. Even number just divide by 2. Take the middle plus together by 2. Okay, so that is steady state. Are we at the end already? No, we still got standard deviation. Okay, how to find standard deviation? Looking at Ethan. How to find standard deviation? I know they give you the formula, correct? So usually formula, there are two things, You have the x, and then you have the frequency, right? So for standard deviation, you need to create another column called the x squared. Okay? Let's say here is 1, 2, 3, 4. You need to create another column called x squared. So this one become 1, 4, 9, 16. Then you take the x squared, then you times the f, and then you just follow the whatever formula that's given to you. All right, so for standard deviation, this is the only extra thing that you need to do. You never do this extra thing, you cannot find the standard deviation. Oh, I still got probability. Okay. Probability got two things, times or plus. Either times or add. You see, addition or multiplication. All right. Now, what is the word? I want the word. What's the word that will tell you that, hey, I need to multiply? What's the word that tell you, hey, I need to plus the probability? Huh? And all? Which one is times? Which one is plus? Yeah, which one is times? Which one is plus? Which one multiply? Which one add? N or all? All or n? Times is which one? And correct. This one is all. Okay? Okay? What do you mean by that? So if the probability say if it's this one and this one, the probability of this and this, you take the probability times the probability. It's the probability of, if they're asking for the probability of this or this, you take the probability plus the probability. Okay, so these are the things that you need to take note of, right? Probability 3, let me go through that. Oh, here's the formula, right? So they give you this formula. Okay, standard deviation. And we are done. Just nice. Well done. 1.5 hour. Okay, now whatever I went through is not everything, all right? But it's what Emath will test you on. Of course, we know the actual questions are twisted, but these are the basic stuff that you need to know. And we're gonna put this into a video. So when you're bored and you got nothing to do, you can go and watch that. Okay, luckily no vectors. If vectors, then you will exceed 1.5 already. Okay, any final questions? Any final questions? No? All right.